India Mauritius STEM Week 2022, the very first edition happening since the 31st of May, and this week at the Rajiv Gandhi Science Center. This India Mauritius STEM Week 2022 is being organized by a joint initiative between the Ministry of Education, Tertiary Education, Science and Technology, and the High Commission of India, and it is being with the collaboration of the Rajiv Gandhi Science Center. So, ladies and gentlemen, dear attendees, it is with very much pleasure that we welcome here today Mr. Srirang Dharmaji Kamble from RITES Limited, Mumbai, India, for this webinar. But before leaving the floor to Mr. Kamble, I would like to invite Dr. Mulu, the Director of Rajiv Gandhi Science Center, for a welcome note.
Okay, hello everybody. Good morning from the Rajiv Gandhi, good afternoon from the Rajiv Gandhi Science Center. In fact, it is an immense pleasure to welcome you on behalf of my board, Dr. Jayanti Nuga, Chairperson of the Rajiv Gandhi Science Center Trust Fund Board, and also from the partnering the High Commission of India for the first time on this special event as mentioned by Hemraj. So we are indeed very pleased to have this series of webinars on various science topics, and this I'm sure will enthuse our students and youngsters in Mauritius, which is the main objective of this event. So this event is also being organized to contribute to the celebration of the 75th anniversary of the independence, given that Mauritius and India have very strong ties on various fronts, and especially on the cultural, political, and science side. So I think it's a very opportune moment to have this webinar. So I will not take much time. I prefer to let Mr. Kamble to give this webinar. So I will pass on to Mr. Ram Kumar, who has been working behind the India Mauritius STEM Week, to say a few words before we pass on to Mr. Kamble. Mr. Ram Kumar.
Thank you, Doctor. Thank you, Mr. Kamble. On behalf of High Commission of India and Government of India, I extend my warm welcome to Mr. Kamble, who has kindly consented to be part of this important collaborative initiative within the Government of India and Government of Mauritius. The India Mauritius STEM Week is being celebrated as part of our India's 75 years of independence. And the very objective of this STEM Week is to showcase what we have collaborated together and what we have able to work together in the field of science and technology. And it is very apt to have someone from RITES delivering a speech on a topic like the health monitoring of bridges, Indian Railway perspective, because the metro is a flagship project between Government of India and Government of Mauritius, and it has been a very important project in the last 6 decades of our joint journey post-independence. So RITES is the consultant for the metro project and who have delivered the project immensely, and it's transformed the transport landscape of Mauritius, be it reduction in traffic, be it economic savings on account of reduction in fuel cost. So metro is there across, and it has been growing popular from day to day, and it has been well received by people. So in Mauritius as well, we have 2 signature bridges, which is part of the metro project. So your topic is going to be very useful for Mauritian audience as well, who will understand the role of bridge vis-a-vis the regular track, which is on the earth, and how this is crucial for a transport network like a metro. So we are again thankful for RITES to participate in this webinar, which is celebrated as part of our collaborative initiative, India Mauritius STEM Week. And I am confident that your webinar and speech would be of interest and great help for Mauritian audience, as well as our colleagues who have joined today, to get new insights into the concept of health monitoring of bridges. Thank you, Mr. Kamble. Thank you, Director Mulu. And I would request RGSC to take it forward.
Thank you, Mr. Ram Kumar. Mr. Hemraj will take over from here. Thank you.
Please unmute.
Hello, can you hear me?
Yes, we
Yes.
can.
Yes. So we have today lots of students from the university students. We have also professionals and professionals in the field of civil engineering. We have contractors. We have people in the construction industry. So it's always a big pleasure to welcome these people on board our webinars. So just before passing on to Mr. Kamble, I just would like to introduce Mr. Kamble, who is actually the General Manager, Urban Infrastructures and Regional Head, Western Region in RITES at Mumbai in India. Mr. Kamble has joined the Indian Railway Services of Engineers, Group A Central Government Services of Government of India in 2000. He has worked in various locations in India as Assistant Divisional Engineer, Executive Engineer, Deputy Chief Engineer, Senior Divisional Engineer, and during these tenures, he has been instrumental in maintenance of tracks and buildings, construction of new assets like track, bridges, and industrial buildings. He has been in charge of design wing of construction organization and implementation of track management systems on Central Railway. He's presently, like I said, serving as General Manager and Regional Head in RITES at Mumbai. So on to you, Mr. Kamble. I would just like to remind all our participants here today, please do not hesitate to ask any question. You can use the chat box or you can use the Q&A box to send your question. I'll be taking all these questions, and after the presentation by Mr. Kamble, we'll get into the question and answer. We'll get into the question and answers. So on to you, Mr. Kamble, and I wish all of you to enjoy this webinar by Mr. Kamble.
My screen is visible?
Yes, it is visible, but you can put it full screen.
Yeah.
Yeah.
So, good afternoon, everyone. Director Rajiv Gandhi Science Center, then High Commission of India in Mauritius, and all colleagues, friends. This is basically a presentation prepared by me. The work in which we are working for 7 to 8 years, like health monitoring of bridges. Particularly for Indian Railways, we will do it in next future. Nowadays, we are doing it for road bridges. So in Indian Railways, we have got about 140,000 bridges. Linear water is almost 960 kilometers, which covers about 600 plus important bridges and 11,000 plus major bridges. Major bridges means it is the linear waterway is more than 18 meter. And the beauty of our Indian Railway bridges is they are quite old. Almost 27.1% bridges are 100 years old. 80% are 34%. So 80 years old, 34% means almost 1/3 bridges we have got 80 years old. And mostly they are arch bridges and some open wave girders, steel bridges. Some bridges are quite, they are in operation, but they are part of worry to the administration because of their health. I will just do some show some photographs, some of the type of bridges on Indian railway system. These are some of the plate girders, then PSC box girders in Navi Mumbai. These are some of the open wave girders that we can call it as through girders. Some of the slick structures with plate girders. Then some of the hydraulic bridges with old stone masonry bridges. These are type of underslung bridges, fish belly type. These are plate girder, fish belly type girders. These are open bridges, open that is underslung bridges, open web, and some of them are in good condition. They are being maintained by Indian Railways periodically. These are some plate girders. So our topic is basically structural health monitoring. So it is just a process of implementing the damage detection. Generally, in our day-to-day life, in our day-to-day monitoring, we go for such type of health monitoring. Particularly, health monitoring involves operation evaluation, data feature extraction, then statistical model development. We'll just correlate with our human system body. So human body is also structure, and most of the time we find some damages in the structure. But before identifying the damages physically, we go for monitoring. Like if we monitor our blood cells, and in blood test we get some parameters, we can definitely say that some issues or some problems are there with the system. Similarly, we can just see that we have got our nervous system, and this nervous system can be similarly work as our sensory systems in our structural health monitoring. It is just a photograph showing that one patient is lying in ICU, and we have got some monitoring system. We are monitoring the parameters, health parameters of the patient. The patient is replaced by bridge. Same system, the monitoring parameters are different, but the monitoring mechanism is same. That means, suppose a patient has some pulse rate, it is more than 100, then it can be immediately given message to the doctor on doctor's phone. Similarly, if we have got any such feature which is going beyond threshold value, then we can immediately get information. So that is the purpose of health monitoring of any age. This is another photographs I am showing that any person who is jogging or running, he can wear some gears, ECG gears, and then temperature gears, movement sensors. And then if suppose something is wrong with that person, then immediately through internet, and through emergency server, it can be given any information which is having more than threshold value to the directly physician. So physician can immediately get alert message that yes, that person is having some problem, and it can be easily tackled. So that is the basically system. We wear smart watches, smart wearable health monitoring stuff nowadays. It's very common, but it is to be linked with the person who can take a decision whether to go for any maintenance issues and solutions. Some of the iconic bridges I will just share with you: the Bandra Worli Ceiling in Mumbai, then Kolkata Vidyasagar Setu, Pamban Bridge near Chennai, and now we are constructing China Bridge. It is the world's highest rail bridge in Jammu and Kashmir. These are some of the case studies. Just for your information, in China, they are doing a lot of health monitoring of bridges. This is 3-tower suspension bridge with 1 kilometer span, each 1 kilometer span. So they are monitoring many parameters like strains, accelerations, and wind speeds for these bridges. And if the parameters are going beyond threshold, they get immediate alerts. This is some iconic bridge, some of the iconic bridges in India. It is signature bridge in Delhi. So they are using some temperature gauges, strain gauges, wind sensors, accelerometers. So many sensors, 100 sensors are there, and they are using 171 channels for the extracting the features. This is one road bridge near Australia, Hunter Bridge, and it is near mining area. So they have monitored abatements and pierce deflections. See, here you can see that the piers and abutments, they are showing some deviation, deflections. So these are monitored by using the sensors. So basically it is time-based maintenance rather than, it is moving from time-based maintenance and we are going towards the condition-based maintenance. So it gives a lot of advantages to the particular structural engineers. Then if you go for the objective, we see the objective, it is basically, it is the monitoring in situ behavior of the structure very accurately and efficiently. Then it can provide reliable information for safety and integrity of the structure, and information gathered from the monitoring can be used for maintenance and management strategies. There are different types of structural health monitoring, like static-based SHM, where we get displacement and rotation. These are static responses of the structures, but they generally need higher static force to get monitoring. But in vibration-based structural health monitoring, we generally get dynamic properties of the structures, like frequencies, natural frequencies, then mode shapes, damping, the strain energy changes. And by these responses, then we can conclude that whether the structure is behaving properly or it needs any repair, maintenance, whether damage is there, or even we can go for damage localization. So SHM, these are the 5 things which we generally focus if we go for structural health monitoring. That is, first point is confirmation of design parameter. During construction also we can use some sensors and we can see that whether our structure is being constructed as designed. Then for quality assurance also we use structural health monitoring. Then the complex structures, basically we design it in our in-house by using softwares. But whether that the structure is behaving properly as per design or not, that also can be seen by using sensors. Then for the safety of people, early detection of degradation is very important. This is also one of the objective and advantage of structural health monitoring. And sometimes we construct the structures which is having more potential. So sometimes it is being wasted because we are not going to have larger loads as designers have not specified. So if we could get the hidden stresses which can be loaded further, so that is also good. Many times structure performance is better than what is designed. So that is what structural health monitoring also gives. These are some steps involved in the system. That is, we have to first identify the structure, then acquire information, then establish the responses for degradation. Then we have to design a system to detect such conditions. Then we install the sensors or design the data acquisition system, the calibrate the system. Then we acquire data, analyze and manage the data. This is the basic step. Vibration-based structural health monitoring, there are different dynamic responses like displacement, velocity, acceleration, as I think all civil engineers or maybe students are there, so they can understand this. And sensory technology, this is emerging field. So I think a lot of sensors are being there in market now, like laser displacement sensors are there, velocity transmitters are there, seismometers, prismatic accelerometers, strain gauges. So nowadays we are using these sensors. We can connect those sensors without any wires also. So the Wi-Fi system and wireless system, we can cater more complicated structures like bridges. These are some of the sensors like load cells, displacement sensor, accelerometer, strain gauges. some file type sensor gauges, crack opening sensors, temperature sensors. This is a typical diagram just to show that in this cable stay bridge we have used electromagnetic sensors. The dots showing on the cable, these are the location of the sensors. These type of sensors are used in electromagnetic sensors. So basically, health monitoring using advanced laser technology and accelerometers. We have got three main parts of the system. It is first is hardware, then software, and data analytics. So hardware contains microcontroller, then nodes, sensors, then single board computer, Wi-Fi router, the server, then sensors like laser sensors, accelerometers, temperature. These are the part of hardware of the system, and these are the purpose of the hardware. As nothing to what to tell about it. These are some of the server used for data storage, and microprocessor are used for data acquisition. Sensors are used for accelerometers for accelerations, like that. So just for some of the sensors developed here. The laser distance sensor, temperature sensors, vibration sensors, and some mini computer also being developed for particular projects. This is also developed here in Mumbai. We have developed a wireless sensor for displacement. In Mumbai, one bridge, road bridge, we have used this sensor. There were some problem of vibrations and displacement. So we installed this at the bottom of the soffit of girder, and it was IP-based sensor. So the message was given. The message can be seen in mobile. What is the data? And it was 24 hours monitoring. So next issue comes in stationary monitoring is localization, because basically any crack or any damage in the structure reduces the frequency, natural frequency of the structure. But if we have two cracks at two different locations or damages at two different locations, then it is very difficult to judge the location of the damage by saying that the frequency has reduced, because frequency can reduce by the presence of the crack, but the damage localization is very difficult. So we are using one curvature mode shape parameter for establishing the damaged locations. So here the mode shape achieved in undamaged structure is overlapped with the damaged structures. So curvature is basically depends on your bending moment, and if bending moment is more, the curvature is more. And if there is change in curvature, then there is always a chance of localization of the crack. So this is how we find out the curvature mode shape. We get it through the displacement mode shape by central difference approximations. In one of the labs in Mumbai, we have conducted experiments at railway laboratory, and we have used small beam, and we have created different damages in that beam. And similarly, we have also modeled in the Abacus software the same beam, and we found that whenever there is a damage, there is a difference in, or you can say reduction in the natural frequency of the beam. And for damage localization, we have used this curvature mode shape. So we have plotted absolute curvature on the by using ANSYS. We have used damage and undamaged condition, and by overlapping these two responses, you can see the peak. So in the first damage, the damage is at center, and in if we plot the absolute curvature difference, then that is the difference between the damaged condition and undamaged condition. We can see that there is a peak at center. So this peak shows that there is a damage. So If there is a damage, then there will be definitely change in the. This is the mode 3. So there we have used mode 1, mode 2, and mode 3 for damage detection and damage localization. The same damage we have increased. So there is increase in the magnitude of the absolute curvature difference. So here also in mode 1, mode 2, mode 3 we got same. Then we created another damage, that is 1.5 meter in 6 meter beam. That is, we can see at a quarter span. So one more peak is now visible. So then we concluded that it is easy to localize any damage by using this curvature difference method. Because damage detection and damage localization are very important for bridge engineers. Because by naked eyes you cannot judge any structure. And if we go for see, time is very important in any structure, because any structure, and bridge is very sensitive structure, I would say. It gives alarming response when it is about to collapse. That is the problem. So, and that time you have to close the traffic, and heavy repairs are there. So initially we can judge the response of the system, and we should be able to get the bad parameters, and immediately after construction we can start monitoring. Like suppose we are at age of 40, so we usually go for annual health monitoring. We check all the your liver parameters, heart parameters, and then blood tests. So a lot of things we do for ourselves. So similarly, when we can say that after 20 years of services of any bridge, we should go for annual monitoring or 6 months monitoring. This is one of the optical fiber based measurement. These are also used for your curvature difference method. So here we give input of flux, and if there is a damage, then the flux will be reduced. So then we can say, yes, there is some difference. There is a damage. These are some of the different new technologies available in the market. These are some of the bridges we have done work on it. This is in JNPT, Jawaharlal Nehru Port Trust, Mumbai bridge. Here the bridge was of beam and girders method of construction, and there were some problems like exposure of steel, then some falling of press, some problems. So the monitoring was for deflection, then flexural strain, then shear strains, and vibrations. So these were monitored for that bridge. And then they had got some scheme of fiber wrapping, carbon fiber wrapping, and they strengthened that bridges. So we have used these strain gauges, electric resistance strain gauges, and displacement measurement and accelerometers. So we have put like strain gauges at the bottom of the beam, then deflection sensor at the bottom of the soffit, omega type displacement, and piezometric accelerometers, and shear strains, temperature correction type indicator. So you see these DAQ for the system. We use these vehicles, 32-ton vehicles, for vibrations. This is the result we can see. That before strengthening, that is the first row, that is before strengthening, for different span, the average central deflections were around 5 mm. And after strengthening, it was reduced to 3.9, 3.65. So there was approximately 27% reduction in the deflection after strengthening. So this also can be monitored. Suppose any bridge we are strengthening, so before strengthening we can take the response, and after strengthening we can take the response, and we can say, yes, there is substantial gain in the parameters, and yes, we have done good strengthening of the bridge. So similarly, flexural strain, before strengthening it was 450 microstrain, and after strengthening it is reduced to 198, around 50% gain we have got in that. Then for shear strain also we have got around 50% in 80%, 80 micro strain was before strengthening, and after strengthening we got around 42 something. So these are just given only 3 spans. Natural frequency earlier it was 5.3, then it increased to 5.7. So when there is a reduction in the frequency, there is a damage. But when there is increase in this frequency, there is increase in the stiffness. So the structure is going to live longer. So here fundamental frequency was increased by around 10%. This is Mahatma Gandhi Setu, Patna Bridge. There inside the girder they have done instrumentation. So these are some of the sensors, the location of the sensors, the strain gauges inside the girder, deflection measurement. This is also Sion Mumbai, Thane Panvel Highway in Mumbai, India. This is very important bridge connecting Mumbai and Pune. So there were also some problems, like you can see in the top left picture. There were some issues of deflection, a lot of high deflection. It was not giving good riding comfort, and it was unsafe also. So they have done some measurements. You can just see that permanent deformation was up to 100 mm, more than 100 mm against the theoretical value of 25 mm. So a lot of damages were there. So then they have done strengthening of the bridges by using carbon fiber wrapping, and they found out that the dynamic properties, the natural frequency of bridge, and it was around. Just I will share the next slide. It was 2.8. Earlier, it was natural frequency of found to be 2.8, which was less than theoretical of 4.9. So approximately 50% reduction was there. So then they went for strengthening, and then they got the proper results. In ANSYS, they have done this modeling, and the model was updated. The model was updated not with the actually construction before. They were the model was created as it is now. So earlier, as per design, they have constructed a good bridge, but after a few years, it got sagged. So the model was updated as SAG model, and then on that SAG model, FRP wrapping was done, then by using laminates and wraps, and then it was done in ANSYS. So this deflected shape just in the ANSYS, just for your appraisal. These sensors were used: strain gauges, LVDTs, thermocouples, then crack openings, multimeters. This is the last slide of my presentation. As Abraham Lincoln has said, that the best way to predict the future is to create it. So we are here to create it. And, structural health monitoring gives it's a basic future of our I can say bridge engineering or structural engineering, because we are in technology world now, and a lot of manual errors we have to eliminate. So Henry Ford has said we can do anything if we have enthusiasm. So I think young generation, the students, they should take it in that spirit. A lot of things we have to do in future for bridge engineering. And, thank you so much for giving me opportunity to present these cases. These are I have just run through because 30 minutes time was allotted to me. But this is, I think, enough for having the structural health monitoring perspective.
Video by label. Video by label. Okay.
Yes, Mr. Kamble, maybe to all those who have been here, thank you very much for being with us. Do we have any questions from the audience? please do not hesitate to ask any questions. I have not received any questions, so any question from the audience, please do not hesitate. We will be here till 3:30. We can be here till 3:30. So maybe I just wanted to ask Mr. Kamble regarding. I've seen you have been doing lots of studies regarding health monitoring of bridges and all. Do you think today we have some students present among us from the university in the field of civil engineering, and we also have some academics? So maybe any field of research, any research area in this sector, you can comment on what avenues do we have for research in this field of health monitoring of bridges. Maybe you could comment if just comment a bit about that.
Yeah. This is basically, this field was used by aerospace engineering initially. Aerospace engineering, they used it for monitoring of planes, flights. So the aeroplanes, they are out of reach of man when they are flying. So it is very difficult if we encounter any problem. So they had thought of monitoring of these planes. So they put some sensors on initially on some wings, then your engine area and body. So initially it was used for planes by aerospace engineering, and then this was transferred to then mechanical engineering, and subsequently to civil engineering. So mechanical engineering, a lot of machines are there, vibrations are there, so they were being they monitored it properly. In civil engineering, it is very new field. Maybe it is 20 years. I would say it is new for civil engineering. Lot of area is there. See, I have just shown you that damage can be detected by using natural frequency. That's okay. But getting natural frequency at site, it is very difficult. See, these are very big structures, and the sensor, putting the sensors intelligently is also very important. So, a lot of expertise is required for that. And then, if we get any data, the data analysis is also big thing. So, because suppose we put some sampling rate, that is data extraction sampling rate, around suppose 100 cycles per second, 100 samples per second. 100 samples per second, if we wait for see 10 minutes or 20 minutes, it is huge data. And from that data, extracting anything like natural frequency and the other velocity, that it is very difficult. So this is not only civil engineering, we can say, but civil engineering, electronics, electrical engineering, these are also can be, we can say it is a multi-engineering sort of thing. And these parameters, like I have just said one parameter, that is curvature mode shape. This curvature mode shape is, I think in 1991 it was used first, 1991 or 1992. So it is not that we can say it is not a new thing to us, but the implementation of that data, implementation of that parameter for particular bridge is very important. See, we are constructing so many bridges, so many iconic bridges, because we are now putting architecture also in bridges. So constructing a bridge is not an issue. You can construct, but maintenance of that bridge and how we will monitor that bridge, that is very important. So a lot of things we can do it. And more these, suppose the response we get in time history, then the time history is to be transferred to frequency domain. So for that, this like fast Fourier transform you use, then wavelet transform you use. That is electronic term. So lot of things are being evolved. So a lot of people are doing research, particularly from China, Korea, and Japan. They are in this research. So I think we can go for further evolution of parameters, further evolution of the methods of structural health monitoring. So a lot of area we can see for future expansion and future research.
So thank you very much. Thank you very much for with us, Mr. Kamble. I don't have any question from the audience, which means that you've been very explicit, and I think we've been very clear. It's always. I have one question which is just coming up, so let me take that. Have there been situations when the results of monitoring is too bad that the bridge had to pull down? So it's a case, have you seen doing some monitoring and you get the outcome of your monitoring turns recommends that you need to pull down the bridge? Have you encountered such kind of situations?
Yes.
Maybe you can
Yes.
comment on these kinds.
Yes, I am not the part of that decision making body where this situation had been. It was even in Mumbai. You must have heard the fall of FOB, foot over bridges, foot over bridge. I think 3 years back, and because of I think monsoon footpath fall. So in Mumbai. The IIT Mumbai and Railway, they had taken a survey of these bridges. They have inspected almost 500 bridges, and in 500 bridges, they found that 8 bridges they were of such situation. We had to pull down those bridges, and we closed those bridges for traffic. And now we are constructing those bridges. So before taking decisions. They had gone for the monitoring of the bridges. The condition monitoring they had gone, and they have taken the parameters, and they seen that now it is not possible to even repair the bridge. Major rehabilitation also cannot be taken for this. So they closed those bridges, and that was good decision taken by the government, because in Mumbai closing any bridge is very difficult because a lot of traffic is there. But they have taken that decision, and now they are constructing those bridges. They are coming up, I think, within a year, they will construct all those bridges. They are on the way. Thank you.
So, okay, thank you very much. I think this brings us to the end of this webinar. I don't know if Dr. Molu would like to say a few words before we leave.
Yes. I think it was thank you, Mr. Kamble. Thank you, everyone who attended us. I think it was a very interesting talk, because we really get the opportunity to hear about specific aspects of civil engineering projects. And we, like I said always in my speeches and talks, science engineering people take for granted whenever they use it. Only when there is problem, when they try to put the blame on scientists or engineers. But I think what you have been doing is really innovating, because using sensors, technology, and all the researchers to monitor bridges, this I think preserves the lives of the bridges, like you compared very rightly to human being. And I think it's a new trend. Like now we are having lots of development with Internet of Things, artificial intelligence. I think that's why, like my colleague asked, there are a lot of research opportunities in this area, and in places even like Mauritius, where we have land scarcity. Where we have land scarcity, there's a tendency to have flyovers, bridges, and multiple what you call spaghetti bridges, sometimes one upon the other. And it's essential for the safety of one and all to maintain the bridges. I think so. For me, as a novice, as a layman in this field, I really appreciated it, and I'm sure our participants in this field in academic from the universities and other sectors. They have at least they have grasped something. So on behalf of the Rajiv Gandhi Science Center, which just to inform all of us that this was the first science center built by the in collaboration with the Indian government outside India. So this is in the context we had the India Mauritius STEM Week at the Rajiv Gandhi Science Center. So our main partner, the High Commission of India, which has been instrumental in having this project to realize this project, and also to have this series of webinars on various scientific topics, especially like Mr. Kamble is from RITES, and I've been apprised that RITES is a major stakeholder in the Metro Express project, as mentioned initially by Mr. Ram Kumar, one of the, I can say, historical project in Mauritius. So this will stay imprinted for decades and centuries after from now. So I think Wright's name also will be imprinted in the history. And I wish to thank you, Mr. Kamble, and from behalf of all my team at the Rajiv Gandhi Science Center, in particular, Mr. Hemraj Ramsaran, who has been coordinating all that, doing a marvelous job, and all the team. We have even met some people in the exhibition talking about rights and stakeholders. So thank you again, and we hope to be able to meet sometime in the near future,
Yes.
or we can even collaborate for some further webinars or seminars. We can see how we can develop our collaborations further. Thank you.
Thank you, sir. Thank you so much.
Just before leaving, I just would like to remind all of us here that the India Mauritius STEM Week is still on, and we will be here. We will be till the 4th of June, this Saturday. So till tomorrow, we've been open mainly to students. Our exhibitions by many stakeholders like the Metro Express Limited is there, Larsen & Toubro, Mauritius Hydrography Services, the Mauritius Police Force. So we have all these, the ISRO is also there. So we have the exhibition, and we have ongoing talks and lectures, and also science shows that is being offered to visitors, to our students as well. And we are also having our series of webinars. Tomorrow we have another very high-level webinar with Professor Das, again, from the Indian Institute of Science, who will be talking on genomics of the SARS-CoV-2 vaccine. So that is also another very high-level webinar for the medical community. And we are also having online quizzes at the Rajiv Gandhi Science Center every day at 7 p.m. online quizzes. But the main information that I would like to share with all of us here is that on Saturday, we are open for the public. So please come with family and visit the exhibitions by all our stakeholders. And you will be also offered with science shows by staff from Rajiv Gandhi Science Center. So please come with family. Everything is free, and you can enjoy science with us on Saturday. So thank you very much, Mr. Kamble, for sparing your precious time with us. It has been a real pleasure to receive you on this platform today. And thank you very much for being very collaborative. Like Director Dr. Balu just said, we just wish to collaborate and to see you soon, maybe in Mauritius someday, for another activity. So until then, thank you very much, and a very goodbye to you all.
Thank you so much. Thank you so much.
Mr. Kamble, bye-bye.
Bye. Thank you.